In addition to solving an equation and finding the number that makes that number, the number or numbers that makes that equation true, we can also look at solving an equation for a variable. So in example 4, we want to solve both of the equations below for y. That means that we want to end up with, in each case, an expression where we have y is set equal to some other expression on the right-hand side. So everything that's not y needs to be moved to the other side of the equation. Any coefficient in front of y needs to be eliminated. In part A, we have a relatively simple example of this. Since we have a plus x on the left-hand side, we just need to subtract x from both sides of the equation. X minus x will cancel each other out. Any number plus its opposite becomes 0. So we can put in a 0 just as a placeholder there. So we'll have 0 plus y is equal to -3 minus x that we subtracted from both sides. That 0 is just a placeholder, so we can just drop that, meaning this is the same as y is equal to -3 minus x. Or because of the commutative property, we can flip that around. That would be the same thing as saying y is equal to -x minus 3. We haven't come up with a number that is a solution to this equation, or in this case it would have to be a pair of numbers that are a solution to this equation. We've just taken that original equation and rewritten it so that one variable is isolated by itself. In part B, we want to do exactly the same thing. Here we have 9x minus y is equal to 7. We want that y variable to be isolated by itself, so we'll start off by subtracting the x term over to the other side, which will leave us with -y is equal to -9x plus 7. And our last step is to get rid of this coefficient in front of y, which in this case is a -1. So we'll divide both sides by -1. What we need to keep in mind is when we do this, each term on the other side of the equation has to be divided by -1. So both the -9x term and the 7 term, that constant term, both have to be divided by -1. So this will leave us with y is equal to -9 over -1 becomes a positive 9x, and positive 7 over -1 becomes a -7x. So we end up with y is equal to 9x minus 7. We don't always solve for y though. It really just depends on the application or the context of the problem that we'd be looking at. So in example 5, rather than solve for y, we want to solve each of these equations for x. So it's going to be that x variable that we want to isolate. We need to make sure we're paying attention to the directions in the problem so we're focused on the right variable to isolate. In example 5, part A, we just need to subtract y from both sides, which will leave us with x is equal to -y minus 3. In part B, we'll start off by subtracting 10y from both sides. So on the left-hand side, all we have is an x term. But we do have a coefficient in front of that x variable, so we need to divide both sides by 2, which again means every single term on the other side of the equation has to be divided by 2, which will leave us with x is equal to -5y plus 3.